the last section for O31, okay? So from here on out, you'll have a worksheet that goes with this, a My Math Lab assignment that goes with this, and then from there on out, you'll just have an attendance grade that affects the O31. The first 8 say, use your calculator to evaluate the following expressions and complete the following formula. So what we're going to do is we're going to use our calculator to find the answers, but then we're going to say, oh, where are these numbers coming from? Can we figure out a formula? So how do you raise stuff to a certain power? So you do 9, and then you do caret, and then you do parentheses, 1 divided by 2 like that. And you just hit enter, and you should get 3 there, right? And you said you guys already had done that.
This calculator is weird.
Why?
It actually like puts a fraction up there.
Yeah. It's updated. That's the newer one. Okay, so we're gonna do 16 caret 1 divided by 2. You guys get 4. Okay, you kind of seen the pattern, right? 25 caret 1 divided by 2 is 5. So, da-da-da! You win! Confetti! It is the square root, right? So notice that all these numbers are just the square roots of 9, 16, 25. But where in their exponent do you see something that reminds you of a square root? The number 2, correct? So anytime you see this guy on the bottom, he's the root you're taking. So this is just the square root of A. So who would have thought that radicals could be expressed with exponents? But they can.
I'm surprised
Mind blown, right? Okay, so what do you think the pattern is with the 1/3 power? You got it. So what's the cube root of 8? Notice when you put 8 to the 1/3 in there, 2 will pop out. So the 1/3 power is the same thing as the cube root. So this will be 3, this will be 4. Is that okay? So again, see that denominator down there? There's the 3, so that means this is the cube root of A.
I like it.
Right? So what is the generic formula? Whatever your denominator is, that's the root you're taking. So the formula would just be the nth root of A. All right, so let's just see what's going on. So what it does, how I do it is I actually rewrite it, okay? So it says, use the above property to evaluate the following expressions. Show work, use a calculator only to check your answer. So how we're gonna rewrite it is what? Yeah, so what root are we taking since the denominator is a 4? The 4th root. But let's remind us what a 4th root means. It means one number times itself 4 times. Well, let's split up 16. 16 is what?
8 and 2.
Or 4 and 4, 8 and 2, it doesn't matter, right? And then each of those 4s are what?
2 and 2.
2s. So do you see 4 of something? Yeah, what do you see 4 of?
2.
2. So what's the 4th root of 2? Or 16?
2.
2. All right? Now this is kind of, we'll talk about negatives. If you're taking an odd root, you can take odd roots of negatives. So notice the parentheses has the negative included, so we want the cube root, and the negative will be under the cube root. You guys might already have them memorized. Do you guys know what the cube root of 8 is? 2. So what's the cube root of negative 8? Negative 2. No. So negatives can be in odds, right? Negative 2 times negative 2 times negative 2 is that. So if you have an odd and you have a negative, let the negative pop out and then just do 8 like normal, right? So negative 2 is your answer there. What about this guy though? What do you notice about the negative? He's not in parentheses. So he's just going to come straight down, and then they just want you to take the cube root of 8, exactly. But what is the cube root of 8?
2.
2, so it's still negative 2 as your answer, right? So with odds, notice it doesn't make a difference whether the negative is part of the root or just outside of the root. It will be a negative answer no matter what. Now with evens, it's different, all right? So let's look at example 4. This negative's not part of the root, so he's just going to come straight down, and then what's the square root of 100? 10. So what's your answer? Negative 10. Is that okay so far?
Yeah, I'm just having a hard time with it.
Oh, I thought this was still square root. It'd be positive.
The square root is positive, but who's in front?
The negative comes down because
So this says I want the negative of the square root of 100. What's the square root of 100? 10. What's the negative of 10? Negative 10. So if the negative's on the outside, it just means this number is negative. Squaring squaring makes things positive. Square rooting has nothing to do with making things positive. But look what happens over here.
It's gonna be the same thing.
Well, where is the negative going to be this time, though?
The whole thing. Oh wait, now it's gonna be positive. Wait, hold on. Let me try to do this.
Wouldn't it just equal negative time?
I don't know.
Can you have a negative under a square root?
No, it's an I.
Right?
Be 10i?
It's just 10i, right?
Okay.
But for purposes of this lecture or this lesson, it's just, we'll say no real answer or real new number. Meaning in the real number system, right, it doesn't exist. Let's put in parentheses 10i because we know that, right? So what does that mean? It means if you have an odd root, the negative can be on the inside or outside, that's fine. The answer will just be negative. If you have an even root, the negative can be on the outside, but you cannot have a negative under an even root, okay? So then, this is just saying, hey, remember that lesson we had last week with negative exponents? Negative exponents just mean I'm in the wrong spot. I'm just going to flip, all right? So this is not really 16 to the negative 1/4. It's the same thing as 1 over 16 to the 1/4, right? A negative exponent just means you need to go in the denominator.
This is the stuff that I gotta get it until I try to do it.
But the 1 hangs out on top, and then how can you write 1/4 as a radical? Yeah, the answer is 2, but I'm going to write it first.
Like 1
You're right, though, Braden. Okay? We just did the 4th root of 16 right up there on example 1. What was the 4th root of 16?
2.
But where's the 2 located?
bottom.
In the bottom. So what's our answer?
Okay.
1/2. You got it. Same thing with this. Notice it's not a negative 100. It's 100 to the negative 1/2. So that negative means I need to go to a different location.
Oh, I did it right. I didn't
Yeah.
look at you.
And then what's 1/2 power equivalent to as far as roots go?
So that would be 10.
Yep, so it's just 1/10.
I gotcha.
And then last but not least, this negative exponent means it should be 1 over negative 27 to the positive 1/3. But the 1/3 means what root? The cube root. The negative 27 goes on the inside because the negative's in parentheses. But a negative with an odd power is fine. What's the cube root of 27? 3. What's the cube root of negative 27? Negative 3. So this is just going to be 1 over negative 3 or negative 1/3, negative 1 over 3. That negative can go anywhere. Okay?
That one kind of confused.
All right, so are you okay with the negative exponent means you need to go to the bottom?
Yeah, but why is that still negative? A negative
Because you're taking
27.
what times itself 3 times makes a negative 27. Remember, that's what cube roots are.
Oh.
So what's the only way you can get a negative 27? There has to be some negatives in there,
I
right?
just thought if you put the 1 on top, you have to get rid of the negative.
The exponent,
Oh,
only with the
okay.
exponent. So notice our exponent turned to a positive. So, and that's really good that you remember that. So whenever he goes to the correct location, he's positive. He becomes happy. So the exponent came to 1/3, but a negative exponent's way different than a negative number, right?
Okay.
So the exponent went to a positive 1/3, but negative 27 is just a negative 27. He's going to be negative 27 throughout. Did you have a question, Braden?
Yeah, for example number 3, do we have to have that negative directly by that 3?
No. So I typically just make the whole thing negative. So I'd write it as negative 1/3. But you could have a negative 1 over 3 or a negative out in front of the 1/3. You just need one negative. He needs to be somewhere, okay? So like you can do this or this, right?
Weird.
They're all the same. Well, it's not really that weird. You know division rules. A positive divided by a negative is a negative. A negative divided by a positive is a negative. So it's just division rules, right? If you have one positive, one negative, ultimately it's negative. So it doesn't matter where the negative goes. Okay, so new rule here. It's actually derived from this guy. So we saw this guy last week, the power to a power rule. Whenever you had a power to a power, you just multiplied. So what we're going to do is we're going to actually do the reverse. We're going to split it apart. So we can write this as either a to the 1 over n to the m, or, actually, no. I'm going to rewrite that, sorry. Because we know what that 1 over n, it can be rewritten as. The nth root of a to the m. That's one way we can split it up. So anytime you have a fraction like 3 over 4, you can think of it as 3 times 1/4. So you can kind of just pull the denominator out and let the numerator hang out. And so that's what it's doing. It's pulling that m out, leaving the n there. And why does that help us? Because we just learned on the front page, 1 over n power is the nth root. So we'll take the nth root and then we'll raise it to the n power. But I also want you to know that there's 2 ways. So I'm going to put a big or. You could have done the other direction. You could have left the exponent there and pulled out the fraction if you wanted.
And it doesn't matter.
And it doesn't matter. So how would we write this?
Because it's the same.
And it's the same. I'll tell you which one I kind of prefer because I think it's easier if you're doing stuff by hand. So when you see a number raised to a fraction and the numerator's not 1, the top number is always your exponent. So whether the exponent's on the outside or the inside, the top number is always the exponent, and the bottom number is always your root, okay? I prefer this method because this ends up being like a really big number underneath, and then remember to take an nth root, you have to like factor it and find out. So I like to say, let's take the nth root of the smaller number because that's easy, and then raise it to the power, okay? So you just found the 2 rules, guys. These are the 2 rules. We can write a to the m over n as the nth root of a, all raised to the n power. So basically it says, focus on your denominator, find the root first. So like you know how a 2 popped out on the front page? Well, a 2 will pop out, and then maybe we have to cube the 2 or something like that. And then this one just says, okay, actually you can raise a to the nth power first and then take the nth root. I like him, okay? Because again, if we're doing all this by hand, it's easier to break smaller numbers down and then raise them to powers than break big numbers down. Like this might be 625. You're like, I don't know what 625 is. And so it's easier to kind of break down 5 and then raise it to the 5th power, okay? So what we're going to do, if you agree with me, is we're going to lean towards the left one. You can do either or. You're not wrong, you know, you can go the other way. But what we're going to do is we focus on the root first, all right? So how are we going to write this? Notice the denominator is a 2. So we're going to take the square root of 25. But after we take the square root of 5, what are we going to do with it? Cube it, okay? So it just has an extra step, right? So it really, the rule, if you think about it, worked for the front page. 2 came out and then raised 2 to the 1st power. But what's 2 to the 1st power? Just 2. So really the rule works for everything. So what's the square root of 5? Or 25? I just told you the answer. 5, right? I do that a lot. Freudian slips, is that what it's called? And then we raise it to the 3rd power. You got it. So what do you get? 125. Awesome. So we'll do the same thing with 125. We're going to take the cube root first. So we'll write the cube root of 125 first. But once we get it, we're going to raise it to the 4th power. So this is what I'm talking about. You could do this method, and you could take 125 to the 4th power, but what is that? That has to be huge.
Pretty big.
It is 244,140,625. Then take the 3rd root of that. It's hard. So I say, let's just deal with the smaller numbers first. What's the cube root of 125?
Well, that's 5.
5, and then you raise 5 to the 4th, and you get what?
625.
Is that okay?
I like this.
I have fun with it too. I don't know why. Okay, so then just keep in mind negatives just means this whole thing needs to go to the bottom. So this is really 1 over 16 to the 5/2. But all we're going to do is 16 to the 5/2, just like we're doing everything else. Just remember it's in the denominator. So that 1 tags along, right? So we can write this as 1 over the square root of 16 raised to the 5th power. Again, instead of raising 16 to the 5th power and then taking the square root. So what's the square root of 16? 4. So we'll have 1 over 4 to the 5th. That's still a pretty big number. What's 4 to the 5th?
1024.
Oh gosh, okay, so it's 1 over 1024. These are kind of hard to see. So what is 64 to the 1/2? Well, that's easy. That's just the square root, right? What's the square root of 64? 8. You got it. And feel free to use that calculator because we have it, right? What is 64 to the 1/3? The cube root of 64. So it's just, what'd you say? 4? What about 16 to the 3/4? Well, we're going to do the root first, right? So we're going to do the 4th root of 16 and then raise it to the 3rd. Well, we already did it. You guys are going to like kind of get similar problems. So notice we already did the 4th root of 16 already on the front. The 4th root of 16 was just 2. So this is 2 to the 3rd, or 8. And then it's 8 to the -4/3, which means I'm going to write it as 1/8 to the +4/3 now that he's in this happy spot, which means it'll be 1 over, again, do your denominator first, the cube root of 8. But once we figure out the cube root of 8, we're going to raise it to the 4th power. The cube root of 8 is 2, is that right?
Yeah.
And then 2 to the 4th, 16, right? And that makes sense because the 4th root of 16 was 2, so 2 to the 4th should be 16. So this is 1/16. Is that what you guys got? Yay! Okay, so all of those that we just did, we actually could just type in our calculators with exponents. But the reason why it's really important to know the steps is because sometimes you'll get variables, and you can't just type a variable in here. So let's rewrite all these using radicals. So this is going to be what kind of root for example 1?
So it'd be x squared.
Yep. Not x squared, the square root of x. You're done. What's example 2?
4th root of y.
4th root of y. You're done. Now this is a little different, but all it means is to keep x and -2 together. So it's just going to be the 5th root of x minus 2. And if you want parentheses around it, you can. It doesn't matter. As long as the whole thing's under the root, you don't really need them. All right, how are we going to write this guy? Well, we can write him either way, but I would do it like how we've been doing. The 4th root of y, correct?
To the 3rd.
Yep, and then we're going to raise that to the 3rd. So how do we do example 5?
7.
The 7th root of n to the 3rd. And then he's just kind of like example 3. We're going to do the 5th root of x plus 1, but then raise that whole thing to the 4th. Yay! Okay, so then the last 3 are just, can you go backwards? So if they give you a radical, can you put it as a rational exponent? And you can. Remember
the 1/3.
yes, the root is your n, the denominator. So this is just n to the 1/3.
Y to the.
So remember the root is your denominator. So what's going to be our denominator? 5. Yep. And so the remaining guy is your numerator.
Do it.
So he's a little bit different. So let's kind of do him in 2 steps. We'll leave 1 over, but this is x to what power? Eventually, right? You got the right answer. So right now, if I leave him in the bottom, it's a positive exponent of what? What's the square root? Yep. But then, Braden, what do we need to do to show, hey, he's in the bottom? This is really x to what power? Negative 1/2.